Hello, welcome to this evening's TI Technology webinar hosted by Texas Instruments, where we will explore classroom-ready algebra activities where students develop mathematical models to analyze real-world problems and evaluate decisions. I see that many of you are joining us for the first time, so we'd like to give a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing that live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm very happy to introduce our two panelists tonight, Karen Kemp and John Lemaster. Karen was instructor of mathematics education at Yale University for 15 years and previously taught high school and middle school mathematics for 13 years. She has been a T-Cubed national instructor since 1998 and has been author of materials for summer workshops and TI instructional websites. Karen speaks often on how to use technology effectively to enhance student understanding. Thanks for being with us, Karen.
Glad to be here, Mike.
And John enjoys teaching mathematics at Indiana University, Purdue University, Fort Wayne, where he uses graphing technology daily to engage students. He has been a part of the T-Cubed family since 1993, presenting annually at conferences, providing professional development workshops, writing math activities, and serving as a consultant for Texas Instruments software and products, including the latest TI-84 plus C Silver Edition. Thanks for joining us, John.
It's great to be part of this.
We are expecting a large crowd tonight, so your audio is muted. I see many of you are using the chat window, and we'll be doing that tonight, so feel free to send any questions that you have using the Q&A window. We'll try and get those questions answered live. We'll also be using the chat window to send general messages back and forth. Once we move to the software, the right section of your screen will be replaced with a floating toolbar. You can access the Q&A window and the chat window by moving your mouse underneath the green floating toolbar once we start sharing our desktops. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. And once that recording is available, if you'd like to follow along with your handheld or your software, and we really hope you will, we do recommend doing this with the recording. That way you can pause that recording and download the activities and move through at your own pace. We don't expect you're going to have any audio issues tonight, but in the unlikely event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, John is going to discuss our agenda.
So hopefully what we'll start off with is showing how the TI-84C can be used to progress through the modeling cycle, and we'll start that with a fish pond activity that I'll share with you involving guppies and frogs. And then after that, we'll see Karen sharing with us an optimization activity and a breaking distance activity that will also round out the evening. Now, if we have time, we might do piecewise functions, but we'll do the main course first before we'd have any dessert. And as you see also on the slide, there's an opportunity for online resources. We'll share that with you too. So Karen, can you share with us the expected outcomes?
Tonight we're going to explore classroom-ready algebra activities where students are developing mathematical models to analyze real-life problems and make decisions. We're also going to learn how to enhance the students' descriptive and analytic modeling by using multiple representations. And this is nothing new. This isn't new with the Common Core. Multiple representations have been an important component of our teaching for a long time. And the last thing we're going to do tonight is learn how to stay in touch with social media and learn about some upcoming TI events.
Thanks, Karen. John, it's all yours.
Great. What I'd like to do is get started right away with showing in an activity, many of the things that you'll see in the Common Core standards. And this activity starts off with a question that I'd like your help kind of pretending if you were a student in this classroom, what would your students say? So we've got this large pond, we've got guppies in it, 300 at least, and 160 frogs. Now, the guppies, they increase by 25 per year. So maybe a pickup truck comes with some guppies and throws it in the pond, or maybe they do it the natural way, you know, we won't go into that. But the frogs, they increase by 25% per year. Now, in the chat window, what I'd love for your help with is, what would you see is the future for this pond? And so what we'll do is get the guppy problem here. And this handout actually has it's in Word, that you're going to get this handout, and you'll see lots of opportunities where you can change the questions to meet your students' needs. And while that happens, let's see, do we need, because I've shared the desktop, any help, Mike, from people knowing what to do to get the chat window to show, just to remind?
Yeah, thanks, John. So again, that chat window and the Q&A window if you want to ask questions, or I think there might be chances, as John mentioned, of interacting with John and Karen as we go. And again, I see many of you are again using that chat window already. That chat window and Q&A window, which had been on the right-hand side of your screen, is now underneath that green floating toolbar. So if you just move your mouse underneath that toolbar, you should be able to bring up the chat window, and the Q&A window has like a little question icon. So I think you're
great.
Good to go.
So we've got some responses. In fact, we've got a big pond in there, a big frog-infested pond, it looks like. Yeah. So there's great ideas. And what might be interesting, as I do this in my classes, I ask then students to say, okay, so you think the frogs are going to overtake this. What is the number of years it'll take, do you think? Predict. What number of years will, and I'd like you to do that too. Can you throw a number on the screen on your chat of how many years is it going to take for these frogs to overtake the fish? Right now there are only 160 compared, there's a little more than half. And then when they write their number down, it helps with the critical thinking, because you'll see in the modeling process, we're going to expect them to then reflect back. What is their, what's reasonable when they do their solution? And yeah, right, what's the capacity of the pond? You have a great question. All we know is really it's a large pond, so we have to say to ourselves, okay, if I had that information, would that influence my answer? Or maybe they'll overtake it before the pond's all dirty water and, you know, dead frogs in it. And so 4.5 years, that's pretty cool. Should we assume this is the net gain per year? Essentially, yes. The net gain of 25 guppies per year is all we get. And that's another great thing. You're assuming there's a bunch of stuff we're leaving out, like, are these fish doing anything to make more fish, or are we just only getting 25 fish a year, and that's all we have? Nice. Now, when we write these out and put them in like a think, pair, share, what the students have then, I'll write them on the board, and then I'll throw candy at the best guesses. You've already gotten into the next piece, the next question, just by your thinking about the problem, which is exactly what I hoped you would do. And it's what factors might impact the growth of the guppy and frog population. So this is really tying into that real world situation. Now, yeah, we're in an algebra classroom. In a calculus, you can see this model is just a stepping stone. We're going to make it more complicated as we go. The pond size, do we need to know the pond size before we find it? And it looks like it's off the screen flowing there, so we might have more pond than just what shows on the picture. So when we look at this, now next rule, what I'd like to do is get a simulation of the guppy and the pond on the home screen of the calculator. And so we're going to get our calculator to roll in. introducing our calculator here. And we already have 300. We're going to first do the guppies. So we'll add. Tatum had a great question. How many frogs and guppies die each year? Aren't you wonderful? You're thinking very good about what assumptions can I have. Are we even assuming any deaths? You know, in this model, we've got some simplifying assumptions here that may be something we have to reflect on. So here we have those 300 fish, those guppies, and if I decide to just hit the plus sign, I will assume that that's the previous answer that I'm adding to, and I had in my model description us 25 growing. So based on the level, you can see many of you are already discussing that, and that's a great topic too. I love this chat. You guys are awesome. That you have different focus of what's important. And what's cool about our home screen is I'm going to circle my arrow right here around the ANS plus 25. That's actually an entry, and down here on the calculator, that second entry will replay that, and now 325 is the answer, the ANS. This is the answer over here on the right, the ANS plus 25 on the left, and just hitting enter repeatedly gives me a growth that simulates that 25 every year. Now this is a very one way that I could model it right on building a table on the home screen. And what I like to do in my handout is then, I'm going to roll this away a little, is show, well, I think I need to have both of those showing. So I'm going to bring that down here and roll it just a little smaller. That we see this idea of now and next. If I have both of those, let me get some screen showing, that I can ask what would be the now and the next with the rule. So if I look at the next, it's the, well, you can perhaps help me. Is there any way to tell how many times I entered? Only if I count, but there's a better way. You're going to see that yes, there is a way. That is a little more complicated if I used a list. Tatum, if you throw me your email, I'll send you that. I know I won't have time for that right now, but there is a way to index these things on the home screen. But there's also another way with the table that you'll see as well. So what I will push for, and my students will try to get, is that we'll see this model here in the formula in a recursive way that, oh no, I like the question, Tatum, it's a good idea, that you can get the matching here. And so here's our table. We've got this built in here. Only after 6 years we can kind of get this essentially build in this table. And let me show you that I have that rolled over here already made. That what is going on now are representations here of the table as well as the home screen. You can do everything I've done on a TI-83. It's wonderful stuff. Now, what the question in the handout will ask is, how does it change every 2 years? So you can push for rates of change here. Giving you a lot of screens, so apologies there for that. Every 2 years, and you can see that I'm growing by, instead of 25, but I'm going to go by 50, and that can be utilized a little nicely with the grid. If I wanted to graph by hand in my handout first to say, well, all right, looking at my data, every 2 years I climb 50 if I use my grid. And so we can speak of rate of change, and then we can now push for a formula. So we're going to formulate the model using some of what we've done here, and we can then get the formula from these 3 representations. And that's the hardest part. As you and I know, if we can get that from our students, it's time to celebrate. And so now we get the explicit formula. And so the explicit formula is, Tatum, where you're going to get the advantage now of getting those as okay, well, Karen, you said that. Good job. All right, that you get that counting. So let's put that in the calculator and push for that. We're going to see that since I change every 25 and I start with 300, hopefully your students will find, I'll get that on the screen here, a nice rule. And I will see this hopefully matching. Now they've already had a little bit of ideas about linearity before this model, so they can get that. And this is the TI Smart View. And I'm going to have to use X instead of T. And I built my window already to match what was on my screen here by using my X-min and X-max and my X-scale and Y-scale and so forth. So if I just hit graph, behold, I have validated what I was doing before. And here, you had asked for this, so let's show that. If I hit second table set, and I make sure I start at 0 and then climb by ones in steps, I can see that, yes, indeed, what I have here matched what I built on my home screen. So I can go from more concrete work here to more abstract work here from the formula, and in fact get in any value I want. So I've got the years, so I can see it, these values. All right, so that's the idea of this first half of this problem. And what I'd like to ask is, kind of looping in back with this, is what is the population of those guppies at year t equals 10? So here's the graph on the calculator. We've got the table right there. On our 83 or an 84 non-color, we would scroll a little. But our table should show a confirmation with our graph. So we can make those connections that, okay, here's 550. Here at 10, we're off by 1 grid mark up there. And we can also predict with our formula. Remember that we had, we can just stick in a 10 in there and 250 plus 300. So really great stuff that models this cycle of let's look at what we've done and if we need to modify. Now, oh, Jeanette, thank you. I'm glad you threw that in the chat. We are such a helpful group here. All right, so now, we can't forget the frogs because they're going to show up. And so I'd like to point out the frogs are now growing, again, not by 25, but 25%. And here's a way we can talk about geometric representation. If I had, you can even imagine taking a strip of paper that's marked out at, say, 160, representing 160 frogs. And if you folded it in half twice, you'd have it in quarters. And you need to grow by 25%. So if you grab exactly the amount of a fourth of that and get some tape out on your paper physically, or have students do that, you kind of predict that this is how much it would grow. So there, what I ask my students to do is now look at that, and there happen to be more than 25 growing, right? There's 4 tens, so there's growing by, well, 40 plus 160, we have a 200. And so they get this idea with this geometric, and my students often have trouble with this idea between linear and exponential. So we're going to look at a 2-year growth, and what is important is then grabbing in the idea here of the next growth, and I'm going to throw that on here and see if I can plop it in there. I'll put it right here. I'm going to roll it in here. And I'm going to now cut that piece of paper and put that into force. And you can see that I have to grow 200. This was 200 frogs. And that might be easier also by sticking in some tens. Say that that's 160 plus 40. And then that is much more than same amount. So there's 5 tens. So in year t equal 2, how many frogs do I have? And look at what friendly chat going on. You've got 200 plus another 50. Now, my students sometimes appreciate just a little bit of concrete building blocks to make sure that they don't just ram numbers into a formula. And that can be tricky for the situation because when you start just saying, okay, this grew by 40, that grew by 50, sometimes they might look at patterns and they'll say, hey, maybe the next thing grows by, we start at 160, it grows by 60 next. And so they might come up with other strange formulas, or they could say this is the formula. And I would like to try instead to do the simulation on the home screen with our calculator before we rush to the formula. So we'll stick in 160 frogs. And now we're going to grow by, we're going to take those 160 and add 25% to them. Oh, and as often happens, we get a surprise when we don't hit second answer because I'm not watching what I'm doing. So second quit, sorry. And we get there. Third time's the charm. Second answer. And so one model is this. You have the previous amount and you grew by 25%. And it does match our 200. But if you have students in groups, isn't it wonderful when multiple answers show up and you can see the structure and make use of the fact that there's some equivalent stuff happening in seeing that in writing that in that way, and then we just hit enter and build. So that's wonderful then when we start looking at these frogs, and we have to then stop and ask now, what does year 3 mean if I'm getting this? And that can be kind of tricky because we've got, you know, nobody's pregnant, right? So 312, we have to then use some number and quantity understanding of what does that mean. So we've got, you know, some, yeah, that's right, 313 frogs there is our ballpark. So we've got these numbers now that we make use of. Okay, so the frog equation shows up, and we can then check our table. I'm going to check my table again, and I've got red here as the color. This, if I really were in the ideal world, would match what I had on my home screen, and I can use the view cube on the Smart View to show, well, it doesn't show everything, but I can change my view to on the view cube option to show the home screen if I wanted to. So I could maybe. No, I couldn't. I'm just surprised. Okay, those are the choices. So we'll just say that was great. That's another wish we would like. But that doesn't match. So we now go back and revise. And we have to fix this. And you probably already know the answer if you have done this problem before. Yep, and so we've got the exponential model. And why not, we can highlight this feature. I'm going to hit second enter to roll all the way over there and get to the, save the surprise there, get to that colored area and hit enter. And this spinner will enable me to make my color green. Now we feel Kermit-like. Okay. And we'll see how good your guesses were when we hit graph. These were in check marks of 1. And so there we are around 4. Someone gets 4.5. Real quickly, a second intersection, second calculate is one other way you can do this. So I ask for the calculator to intersect. And it's going to ask me what's my first curve. I could hit enter. It'll bounce to the second curve. And I can even either guess or I can even type a guess, and it will land at 4. And then I have to interpret what that means. Now, wonderful stuff. But here's the last part that what are those limitations that came up? And this is back to the chat that I would like to ask for your help with. And we see that we do have some issues because, right, you've got a pond capacity. So if someone was saying, well, I need to know the pond size, after 4 years, they've overtaken. If they've outgrown the pond in 3, you're right, we've made an assumption. So we can go and, someone also mentioned death of the frogs, and we can build those into another assumption, model, which we'd go back to do. Now, Karen, I don't want to infringe on your time, but I want to probably then move right to the modeling PowerPoint to show these things. Are we okay with that?
Sounds good.
Okay, great. All right, so here's essentially then what we were showing with the ideas in this activity. And you've got some content categories out there. And what's nice to see is, when I hit that modeling it's a mathematical practice, but we also can see that it's a content category in itself, and it has stars in all of these other categories, including the entire statistics category. Stars indicate that's where modeling happens, and the entire quantity domain happens. And look what we've done. Our first thing was we had to figure out the variables in the problem. So what's the issues we can ignore or keep? We made a representation. That might have been a graph, a table, a formula. We formulated. And then we found our answer through either solving or computing or analyzing by tweaking. And that required us to say, what does this mean? What does this mean in the context? Does it make sense? Only by looking back can we make sense out of it, by having had chance to say, all right, predict. Does this feel like you should do this? Does it make sense in the real world? Which was many things you were doing in your chat. And then, okay, let's validate. Remember, I used my table to validate my home screen. Then I made a revision if I didn't like it, or if I did, I reported it and celebrated. So that's our modeling cycle. And you keep going through your cycle. And I will just point out there's these proficiencies that you'll see in the mathematical practice that they mention. And we've seen this, representations that are connected, and identifying the quantities, and applying, and making assumptions, and then looking at the context. And so you can see all of this. All this slide will be in your materials that you'll get. And that big solve indicates that that was that analyze right here, that compute, that you can find the answer to the problem, which sometimes all the textbooks have there. Finally, then, you'll see that these representations show up in many ways, and that's from the Principles and Standards 2000. So that's all I want to share, because I shared more than I want. But when I now look back at the ideas, that's how you can interpret things. And in the teacher's notes of the handouts, I'd like you to see that you will have many of the stars showing up that you're going to get. Karen, I'm so thrilled to hear what you have to say, so I want to get you started right off the bat, because I know I stood a little bit higher than I thought.
No problem. Let me show you our next problem. And the next problem is the problem about building a rectangular dog pen. And one of the things that we have to guard against when we're doing modeling problems is making sure that our problems aren't too cliche and too easy for the students to just give us an answer. But what I'd like you to see with this activity is that it's not just going to be the answer that we all predicted. I think that if I asked you to put in the chat what you predict, If you have 200 feet of fencing to build a rectangular dog pen and you want the maximum area, what should the dimensions of the pen be? And I'm sure that many of you have suggestions of what that pen should look like. The second question we're going to look at with this is, what if the pen is along the side of the house, to make sure that it's not just a cliche kind of question. What I want to do is I want to take a look at this activity. Here is a rectangular pen, and I'm going to let the base of it here be x and the height be h, and my perimeter, my fencing that I have available is 200 feet of fencing. So solving this equation, 200 equals 2x plus 2h, I'm able to get the expression for h, that h is 100 minus x. So h equals 100 minus x. And once I know that, now I can build a formula for my area. Take that area formula and express it in the, I've expanded out my multiplication. And now let's go to my TI-Smart view. And I'll put in, got to remember what I had here, 100x minus x squared. And in order for me to get a good window, if I start here on a standard window, one of the things I want students to think about is what's an appropriate domain. Going back to our diagram here, our visual representation, we've got a total of 200 feet of fencing. My h is going to be 100 minus x, so x could be 0 or x could be 100, and so that's going to help us set our x minimum and x maximum. And then we're going to go down and also try to get an appropriate y minimum and y maximum. And I don't really know what the y maximum is going to be. I'm going to start with 1,000 and set my y scale and go ahead and take a look at the graph. And clearly my assumptions about the x value of the domain was good, but I'm off on my y value. I'll try for 3,000. And just a tip, by the way, if you go to start graphing something and you know that it's not going to work, if you press the on button on your calculator, it's going to break the graph. It's going to stop that graphing for you. And if you want to pause the graph, press your enter button. That will pause the graph. You see this little circle is continuing to go. And then we can press enter again to finish the graph. So here we've got a beautiful quadratic model. We looked at this geometrically here. We look at it algebraically and graphically. Just before we go ahead and find the maximum of this, I want to show you very quickly that you can also take a look at a dynamic geometry representation using the Cabri Jr. app. Geometry is one of my favorite things, and I'll actually be talking about the Cabri Jr. on the TI-84 color calculator at our international conference coming up next month. And you're going to get a Cabri Jr. file in your documents tonight. There's going to be 2 Cabri Jr. files. One's going to have a C at the end of the title, and that's for the color calculator. And the other one's going to have no C, and that's going to be for the regular 84. And the reason is that the color calculator has much more pixel depth. And so with more pixel depth and density, our numbers, our measurements are going to change. So what I've done here is I've modeled this same amount of fencing, except I can't do 200 units of fencing on my little Cabri Jr. screen, but I can do 10 units of fencing. And one of our problem-solving techniques is to use a simpler problem. And so the distance from A to B is modeled as 10 units of fencing. And if I grab point C and move it back and forth, I can get a dynamic model and show what these different perimeters and areas work out to be. The perimeter in this situation was 20, and my area, when I get to my maximum area, it looks like it's going to be at 25. Let's see, can I get it? There we go. My maximum area is 25. And so this is sort of that classic, the square is the maximum area problem. And going back to our graph, if we want to find our maximum area from our graph, we will again validate that it's going to be that square. Second calc, I wanted to show you on the new TI-84C color, as you're moving and selecting your left bound, this information at the bottom of the screen doesn't cover the graph, which is a nice improvement. The other thing you'll notice is that the left bound and right bound, you get to see these nice vertical lines, so it's a really great representation for kids to see. And you press enter, and we find that our maximum X value, the maximum area of 2,500 square feet occurs at an X value of 50. That rounds off to 50. And so that's going to be our optimized area. One of the things you're going to get tonight is this handout. And this is that same question that we've just done. What should the dimensions of the pen be? And now let's look at the second question. You have 180 feet of fencing to make a rectangular pen. One side of the pen will be along a 200-foot wall, so it requires no fence. What are the dimensions of the pen with maximum area? Oh, and I just want to also comment on Leah's comment in the chat. Zoom Fit and Zoom Stat are great tools for the kids to use sometimes, but when my kids in my classrooms first discovered the Zoom Fit and Zoom Stat, the very next quiz I always gave them a data set and said, can you please get an appropriate window? I didn't want them to actually put it in the calculator. I just wanted them to assess and make a decision about that data set, what kind of a window should they use. Kids need to be able to make a decision about domain and range without just using Zoom Fit and Zoom Stat. Anyway, back to this rectangular pen along the side of the wall. Here's this situation. So now I have 180 feet. That's going to have be spread out between the two H's and the X. H ends up being 90 minus 0.5x. Going back to my y equals, sorry, here's my area function. I need to build my area model. So it's 90x minus 0.5x squared. 90x minus, now here, I want to show you, for those of you who haven't done the math print, I want to do the 0.5x squared. I'm going to make a fraction for the 1/2. One of the things that's really important is for kids to be able to translate between different representations and whether the notation works or doesn't work. So here I've got 1/2 x squared. It's worth discussing with kids. Is that the same as x squared over 2? Is that the same as 1 over 2x squared? If I didn't use my fraction symbol, what kind of notation is acceptable in here? All kinds of good discussions you can have about notation. Anyway, if I go back to the screen I had, clearly I need to reset my domain and range. And so it turns out I'm going to make my X max, I'm going to go to 200 now, because I have a total fencing of 180. And I'm going to do my Y max to 4,000, give that a try. And I can see I'm just going to miss that max again. So I'm going to go back and adjust my model. And we'll find out that the maximum here gives us a different number. And I'm not going to take you through finding that maximum. But I do want to point out that in the handout, one of the extensions that that is in the handout is what is the relationship between the vertex of a quadratic graph and its x-intercepts. If you take a look, this vertex and these x-intercepts do have a pretty interesting relationship. The other thing I wanted to say before we leave this pen and fence problem is that you've got other ways that you can get away from sort of that cliche, it's always a square answer. Look at problem C here. A farmer wants to put a fence around a rectangular field and then divide the field into 3 rectangular plots by placing 2 fences parallel to one of the sides. Just to show you what I'm talking about, this is what we're talking about. You've got a rectangular field and then 2 more parallel fences. And you can move them around if you want to, but that's the amount of fencing. So I think that this problem gives us a very rich set of things that you can consider. Let's move on to our next problem. And I got to find it. Here we go. Actually, I want to, on the multiple representations, the last screen of what John had gone through with the modeling cycle, one of the things that's really important about using multiple representation is making students translate among their representations. In other words, if students are used to writing an equation first and then making a graph or then getting a numerical answer, have students start with the numeric like John did by generating those recursive values on his screen. Or have students look at a graph first and then come up with an equation. This kind of translation among the different representations really helps to solidify learning and make students understand these concepts at a deeper level. Okay, so our next problem is a problem about distance needed to stop a moving vehicle, and that depends on the driver's reaction time and the speed of the vehicle. Now, just like with the Cabri Jr. Model, I want to have a visual model, and somewhere I had it. Here it is. What we're talking about is that depending on how fast a car is moving, there's an amount of time that the car moves while the driver's reacting to the obstacle, and then there's the braking distance. This part here is while the driver is thinking about having to stop, and that grows depending on how fast the car is moving, because the car is moving while that driver is thinking, and the car is moving at a faster speed. Then this section is the amount you need to brake that car. So there's a neat graphic. And so our activity here, this is actually from an old activity that's been, this data set has been around for a while in some TI activities. And this is cooked data, meaning that everything works out beautifully. This is not a scatter plot of data. This data models the information perfectly. But what we've got is we've got speed, we've got reaction distance, braking distance, and total distance. And I've put this data into my stat list. Let me just clear out what we were working on. Okay, and in our stat list, I've put the miles per hour data and the reaction time data, reaction distance, and then the braking distance. And so what I want to first do is I want to take a look at the scatter plot of the speed of the car and how much reaction distance it takes. Second stat plot. I'm going to turn this plot on. I'm going to change my mark here. And now again, I'm sitting here in a poorly designed window. We can do zoom stat, but like I said, I would want kids to come up with a good window before they just go and hit the zoom stat. And we're going to have a linear model. And under stat calc, a couple things I want to show you that are different with the TI-84C is that this linear regression is going to give us this little dialog box. This is new. X list, Y list, and then down here, storing regression equation, it's going to give us an opportunity to store it directly into Y1. And I can get that Y1 from my alpha trace, or you can always get it from the Y bars. Then we're going to come down, we're going to calculate, and there's my linear regression. And you can see it put that equation directly in Y1, and it models my data beautifully. The next part of the problem, I'm going to turn off my plot 1, And I'm going to turn on my plot 2. And plot 2 is going to be my braking distance. I'm also going to turn off this first equation, but I'm going to leave it there. And there's my braking distance, and this is going to be a good quadratic model. And so we're going to go ahead and stat calc a quadratic regression. And my y list is L3. And I want to store this regression equation into y2. And there it's done. It's in my y2, and it models it very nicely. So this may be something you've seen before, but what I want to now highlight is our ability to use function notation with these models and to also add up the individual functions. Going back to my stat edit, I have my reaction distance here in L2 and my braking distance here in L3, and my total distance that the car travels, I want to add those up to get my data for L4. And so I have to arrow up to the top of that column, press enter, and it's going to let me actually add up L2 plus L3, and there's that data right there for me. And what I can do now is I can turn back on my plot 1, and I can also turn on plot 3, with my information from L4. Now, it's a little hard to see with just the scatter plots, but the black dots is going to be the sum of each of the other two data points. So now what I'm going to do is I'm going to turn back on the equations, and you'll see that the linear equation and the quadratic equation, maybe you can see, a little bit harder to see that that data is going to add up. But the final piece is I don't even have to do a new quadratic regression. In Y3, I can add up Y1 plus Y2. And taking a look at that graph, adding the two other regression equations matches my data perfectly. The last thing you can do with function notation is back on the home screen. If I care about what is my total distance that my car is going to go when the car is moving at 55 miles an hour, I can actually get the symbol for Y3 and ask the question, what is Y3 of 55? So that works the same way as looking at my graph and asking it to calculate the value of 55 on my Y3. Where's my Y3? There's my Y3. It's off my screen. Went too far here. Okay, and so now I'm trying to show you the different ways that we can get this same information with a numeric answer, with a graphical answer, and using function notation. So let's go back. Whoops, that's the wrong thing. I wanted to do second calc, value of 55 again. Okay. the next thing I wanted to show you before we wrap up tonight is I wanted to just very, very quickly, actually two things. Let me show you one more thing about the statistics. The stat diagnostics, those of you who want to discuss the R and the R squared with your students, in the mode screen, stat diagnostics can be turned on and off right here in the mode screen. So if I were to go back and do one of my stat calcs, if I wanted to do the quadratic regression on L1 and L4, I can do it and get my diagnostics right there. So that's now a command that you have available straight from your mode screen. Okay, the very last thing I want to show you, actually, is the piecewise functions. And the piecewise functions, I think that a lot of times we talk about piecewise functions and we graph them by hand, but we don't have a really good way to do it on the calculator, and I really love this. So if I have this piecewise function, f of x equals negative 2x plus 3 for negative x values and x minus 2 for positive x values, this handout that you're going to get in your materials tonight explains exactly how to set this up. And what you do is you use this math test menu. When I was designing this, I put in the stem of the question, the stem of the piecewise function, excuse me, and then I divide it by a test operator. I divide it by x less than 0. That came from, this less than, came from second test. And so that's when I use the less than. And so this is going to return a value of 1 if it's true and a value of 0 if it's false. And we all know that dividing by 0 gives us no value. And so it won't show up at all. The y2 is the second part of my function, and that's going to give me x greater than or equal to 0. And so when I go ahead and graph this, what is beautiful about it is it's going to show up nicely. I'm not going to see the values that are divided by 0. And when I trace, if I'm on my blue function and I trace to the left, actually I'm going to change this to a zoom decimal because the zoom decimal window is so much nicer for tracing. What zoom decimal window does is it equalizes the number of pixels with your tracing. I need to change my Y max, but otherwise this is fine. And so when I trace on the zoom decimal window, you're going to see that my trace gives me my x values on the blue function, and when I get to the point where the blue function doesn't have a value, I don't get a y value. And if I can keep tracing all the way over, but my blue function has no y value, I have to go down to my red function to get the rest of the piecewise function. The reason I wanted to include this tonight is because the piecewise functions are so useful in modeling real context problems. Well, I think that that's all I have. I'm going to send this back to Mike.
Thanks, Karen. So I'm going to begin wrapping things up tonight. And as I do that, if there are any last-minute questions for John or Karen, I know they'll try and get those questions answered here in the last few minutes. There are a few resources on our website that I'd like to mention in case you're not familiar with them. Again, our website is education.ti.com. And I think it's worth noting, slide down to the Professional Development tab and move down to Online Learning. And on the left-hand side, click on Webinars. So if you like the format that you saw tonight, we do have a lot of upcoming webinars this coming spring, many of which do deal with TI-84 technology. There's one there, middle grade statistics, Common Core. And again, there's a few others that also deal with TI technology or TI-84 specifically technology. So I think it's worth checking those out. Again, all those webinars are free, and you can register for any of those at any time. In case you haven't heard, we released recently a new campaign called STEM Behind Hollywood, and we're really excited about it. STEM Behind Hollywood is a new program that we created with the assistance of the Science and Entertainment Exchange, which is a program of the National Academy of Sciences. And the idea was to really get students excited and energized about STEM education and careers. And so what we did is we brought in scientists and experts who consult on Hollywood films and TV, and they worked alongside leading math and science educators to create free classroom activities for TI technology. The activities center around math and science behind Hollywood themes that are common, like zombies, superheroes, space, and forensics. You can learn more at stemhollywood.com. TI is now on TeacherTube, which is an online community for instructional videos that is educationally focused and safe for teachers, schools, and students. So you can check that out and learn more about our tutorials or solutions and information about webinars. Is also posted at our TeacherTube website. I know that a bunch of us are getting ready for the T-Cube International Conference in a few weeks here, which is going to be in Las Vegas. I'm pretty sure that both John and Karen, I believe you're both going to be there and probably presenting as well. Is that correct?
Yeah.
We are. We've got some great fun stuff ahead, all in the Common Core.
So both John and Karen, you're both presenting Common Core at the International Conference?
That's right.
My presentation is on geometry on the TI-84C, but we will be talking about Common Core as well.
And I'll be doing Common Core activities on the 84 with little surprises that await in each activity.
That's great. Thanks, guys. And I know that if you're looking for maybe other technology, other TI technology, that will be supported there, different content areas, pedagogy. It's a great place to intersect all three of those, as well as networking with teachers from around the world. So we really hope to see you in a few weeks at the T-Cubed International Conference. I did mention that we do have a bunch of upcoming webinars this spring, and they do focus on all the main hot topics that you might find currently in math, especially Common Core is sort of a common theme for this spring. So we do hope that you'll join us in a future webinar.